This presentation will focus on nicotine content and nicotine uptake when cigarettes and nicotine pouches are used either in a standardized way or as desired. Nicotine is what cigarettes and nicotine pouches have in common. In terms of risk, they are very different because no combustion products are formed during nicotine pouch use. A cigarette does not contain 1 milligram of nicotine, but around 10 milligram. Nicotine pouches are oral, smoke-free products that contain synthetic or tobacco-derived nicotine, but no tobacco leaf or stem. They come in different strengths and sizes. The German Federal Institute for Risk Assessment performed several studies on nicotine pouches. Based on their findings, they recommended an upper limit of 16.6 milligram. In a smoke machine, using the ISO method, a cigarette is allowed to emit 1 milligram of nicotine according to the EU Tobacco Products Directive. There is no smoking machine for nicotine pouches. A suggested method by some regulatory bodies is to use dissolution, where a pouch is placed in a small container with liquid. This method often overestimates nicotine release from pouches. A better way to estimate nicotine release from a pouch is to do it in a clinical setting, where participants use a pouch in a standardized way. This includes how and where to place the pouch. Typically, no manipulation of the pouch is allowed during use, and no eating or talking. The usage time is fixed, usually 20, 30, or 60 minutes. Before, during, and after use, repeated blood samples are taken to plot the pharmacokinetic curve of plasma nicotine concentrations over time. Doing this allows for calculations of maximum plasma concentration, time to maximum plasma concentration, and total nicotine uptake, which is the area under the curve. By collecting used pouches, measuring how much nicotine there is left in the pouch, and then compare that to the average content of several unused pouches, the nicotine extracted during use can be calculated. This is how a plasma curve can look like in a single-dose administration study. The cigarette was smoked with 10 inhalations taken at approximately 30-second intervals. The nicotine pouches were of the same type with varying nicotine strength. As you can see, a cigarette delivers nicotine quickly, but is finished after 5 minutes. There's no natural end to a nicotine pouch. Here the fixed usage time was 60 minutes, which is long. What we can see here is that independent of product, the maximum plasma nicotine concentrations are reached around product removal. So when you stop using the product, nicotine delivery also stops. Another thing is that pouch use can result in similar plasma nicotine concentrations as cigarette use, but it takes longer time. Since it takes longer time to reach the same concentration, the area under the curve will be larger. More nicotine has been taken up. This is illustrated in the table showing extracted amounts and fractions. Even though the pouches were used for 60 minutes, up to half of the nicotine is still left in the discarded pouch. So with slower nicotine delivery, a product requires more nicotine than a faster product to reach the same plasma nicotine concentrations. Now we move away from the clinic and standardized use to exclusive users of either cigarettes or nicotine pouches that use their products as they wanted for 2 weeks while they lived their usual life. Then they came to the clinic to have their blood drawn. The pouch users chose pouches containing between 3 to 12.5 milligram nicotine and used on average 10.7 pouches per day. Cigarette users used on average 12.2 cigarettes per day. These two groups had similar plasma nicotine concentrations. Based on the previous slide, we know that nicotine delivery with a pouch is slower, so more nicotine is required to reach the same plasma concentrations as a smoker. 70 to 80% of the nicotine is metabolized to cotinine, a metabolite with almost no pharmacological effect, and it is here that we see the difference. The pouch users have taken up more nicotine. That didn't mean that their plasma concentrations were higher. It's just an effect of choosing a slower product. To conclude, nicotine content is not nicotine uptake, and a product with slow nicotine delivery requires more nicotine to achieve the same plasma nicotine concentration as a product with faster delivery.